Hi, everyone. Welcome to HashiTalks 2025. I am Alia Sheikh, and I am an Associate Delivery Consultant with AWS Professional Services. I've been with AWS for a little over 2 years.
Hello, everyone. My name is Vinita Sharangi, and I am a Senior Specialist Solutions Architect for Serverless and Gen AI here at AWS. I have been with AWS for a little over 5.5 years now. For today's session, Alia and I are going to be talking about securing AWS environments with HashiCorp Vault from basics to best practices.
The agenda for today is we will start with foundations about AWS and Vault integration. Then we will go into some advanced security architectures. We will then follow it with real-world implementations, talk a little bit about compliance and audit, and then we will conclude with best practices and recommendations.
So now let's talk about foundations of AWS and Vault integration. AWS and HashiCorp Vault integration represents a sophisticated approach to secrets management and secure credential handling, specifically for cloud environments. This integration enables organizations to centralize and dynamically manage AWS credentials through Vault's robust secrets engine, providing enhanced security and granular access control. By leveraging Vault's authentication mechanisms, such as AWS IAM and EC2 instance authentication, organizations can generate short-lived, dynamically generated credentials with precise access permissions. The integration supports automatic credential rotation, reduces static credential exposure, and implements fine-grained access policies across cloud infrastructures. Vault acts as a centralized platform for managing AWS secrets, enabling seamless authentication, temporary credential generation, and comprehensive audit logging. Key features include dynamic IAM credential generation, role-based access control, automated credential rotation, and secure cross-account access management. This integration supports multiple authentication methods, including IAM roles, instance metadata verification, and Kubernetes-based authentication, making it a flexible solution for complex cloud environments. Organizations can implement advanced security practices like least privilege principles, implement comprehensive compliance tracking, and maintain robust governance across their AWS infrastructure. The integration also simplifies secrets management, enhances the security posture, and provides a scalable approach to managing cloud credentials, making it an essential tool for modern DevOps and cloud security strategies.
Let's talk about some key concepts. To understand how Vault integrates with AWS, we first need to grasp some very key concepts, starting with secrets engines. These are components responsible for storing, generating, or encrypting data. Think of them as pluggable modules that handle different types of secrets. The second one is authentication methods. These verify the identity of users or machines trying to access Vault. AWS has specific authentication methods that we'll discuss shortly. The third one is policies. These define access rules within Vault, determining what secrets a user or application can access and what actions they can perform. Now, let's look at AWS-specific configuration. Vault provides an AWS secrets engine, which is crucial for our integration. This engine allows Vault to dynamically generate AWS access credentials. Instead of long-lived static AWS keys, Vault can create short-term credentials on demand, significantly reducing the risk of credential exposure. AWS Secrets Engine can be configured to work with IAM users, roles, and even generate dynamic IAM users for ultimate flexibility and security.
Now let's look at some advanced security architectures. As organizations grow and their AWS usage becomes more and more complex, advanced security architectures become necessary. Vault shines in three key scenarios. Let's talk about the first scenario. The first scenario is cross-account access. So in multi-account AWS setups, Vault can act as a central control point. It can be configured to generate credentials for different AWS accounts, allowing for a unified secrets management approach across the entire AWS ecosystem. The second scenario is multi-region deployment for organizations operating in multiple AWS regions. Vault ensures consistent secret management across all the regions. This is crucial for maintaining security standards and simplifying operations in globally distributed systems. The third and the final scenario is hybrid cloud setups. Many organizations operate in both on-prem and cloud environments. Vault bridges this gap, providing a single tool for secrets management across your entire infrastructure, regardless of where it's hosted.
These advanced architectures address several critical AWS security challenges. Let's start with secrets management. Vault provides centralized storage for all types of secrets, from AWS access keys to API tokens and more. This centralization improves security by reducing secret sprawl and providing a single point of control. Then we have access control. Vault's fine-grained policies allow you to implement least privilege access, ensuring that users and applications only have access to the specific secrets they need. And then we have encryption. Vault integrates seamlessly with AWS KMS, which is the key management service, enhancing your key management capabilities and providing an additional layer of encryption for your most sensitive data.
Great. Now let's talk about some real world implementation. Let's look at some practical implementations of Vault in AWS environments. The very first one is dynamic AWS IAM credentials. This is one of the most powerful features of Vault and AWS integration. Instead of creating and distributing long-lived AWS access keys, Vault can generate short-lived just-in-time credentials. Let's look at how it works. An application first authenticates to Vault. It requests for AWS credentials. Vault then generates temporary credentials using AWS Security Token Service. These credentials are valid only for a limited time, typically 1 to 60 minutes. Once expired, the application then requests new credentials. This approach significantly reduces the risk of credential compromise and simplifies the access management. The second implementation is securing AWS Lambda function. Vault can be used to secure secrets used by AWS Lambda functions. So instead of hard coding secrets or storing them in environment variables, Lambda functions can retrieve secrets directly from Vault at runtime. This keeps your secrets out of your code and provides an audit trail of secret access. The third and the final implementation is AWS Key Management Service integration. Vault can be configured to use AWS KMS for encryption operations. These allow you to leverage AWS's robust key management capabilities while still using Vault's flexible policy engines and secret management features.
Okay, let's talk about compliance and auditing. Compliance is a critical concern for many organizations, and Vault provides several features to help meet regulatory requirements such as GDPR, HIPAA, and PCI DSS. Let's talk about audit logging. Vault provides detailed logs of all secret access. These logs can be used for compliance, reporting, and security investigations. Coming to integration with AWS CloudTrail. When used together, Vault and CloudTrail provide comprehensive tracking of all actions taken in your AWS environment, including secret access generation. And then we have access controls. Vault's fine-grained policies help implement and demonstrate compliance with access control requirements. And then we have encryption. Vault's encryption capabilities, especially when integrated with AWS KMS, help meet the data protection requirements.
Amazing. Now let's look at some of the best practices and recommendations. So to get the most out of your Vault deployment in AWS, let's consider these best practices. The first one is deploying Vault in private subnets and using auto-scaling groups for high availability. The second best practice is integrating Vault into your CI/CD pipeline to securely inject secrets during deployment. The third one is conducting regular security audits and keeping both Vault and your AWS resources up to date. And finally, implementing least privilege access using fine-grained policies in both Vault and AWS IAM.
Let's summarize all what we learned today. So, in conclusion, HashiCorp Vault significantly enhances AWS security by addressing key challenges in secret management, access control, and encryption. It enables advanced security architectures and helps meet compliance requirements. By following best practices, you can ensure optimal integration between Vault and AWS. As both AWS and HashiCorp continue to innovate, we can expect even tighter integration and more powerful security features in the future. Thank you for your attention, and I'm happy to take any questions.
Thank you, everyone.